What's going on, y'all? Sean of MathSwap Tutoring here, and today we're going to talk about the closed interval method. This is a method that's used to find maximum and minimum values for a function on a closed interval. Okay. Make sure you like this video. Make sure you subscribe if you're not subscribed already. Okay. All right. So I'm going to provide um some notes. So I encourage you to write notes if you don't already have some, or it might be good to write some even if you do. But definitely above all things, pay attention to what we're talking about here. So this is you. So let me say this. The closed interval method is used to find absolute, maximum, I'm just going to abbreviate, and minimum, and minimum values of a function f on a closed interval A, B. All right. So use to find absolute maximum and minimum values. Okay, so when we say um, absolute maximum and absolute minimum, what we mean is this is going to be the highest maximum, the lowest minimum. Local is going to be more so related to the fact that it may be it may be a maximum or a minimum, but it doesn't necessarily mean that it's the highest maximum or the lowest minimum, if that makes sense. Okay. Okay. Now, so let's look at this here. Oh, and then also, this is on a closed interval AB. If you look at this little drawing that I have here, you see like there's this function with this red line, and then you see that we have this function graph for the interval between A and B. So the closed interval method would help you to find maximum and minimum values of this function in between this interval here. All right, so here are the steps. Okay. So number one, you want to find um okay, yeah, so find F at the critical numbers in AB, and we'll explain this as we after I write it down. Number two, you want to I'm sorry, you want to find F at the interval endpoints. Uh-oh, made it write an S. So that means you want to find F of A and then F of B. Okay. And then number three, you want to compare the largest and oh, I'm sorry. I'm kind of like reading my notes in a faulty manner. So the largest is and part of my abbreviations, the absolute max, and the smallest is the absolute minimum. Okay. So let's recount what this means. And I do have a video if you want to watch that. You might want to watch that on critical numbers. So if you recall, a critical number is a value in the domain of a function where either the derivative is equal to zero or the derivative doesn't exist. Okay, so again, the a critical number for a function is a value in the domain, so some x value where the derivative of the function is either equal to zero or the derivative does not exist. So when we look at step one here of using the closed interval method, what we want to do when I guess to find f at the critical numbers, that means that we need to find the derivative first of all. So we're going to find the derivative and we're going to see where the derivative either is equal to zero or where the derivative does not exist. Okay. So let's go ahead and do that here. Let's scroll down some. I'm going to try to scroll so we can keep the steps on the screen. And we're going to go ahead and do an example just to kind of like illustrate this. Okay. So let's say you have the following: f of x is equal to x to the 3/5 power times 4 minus x. Okay. So we want to find, okay, let's see. Hold on a second. There's a part of this that I guess I didn't write down here. Give me a second. Okay, so I just realized that with this example that we're about to do, that I didn't have an interval actually in my notes. So we're gonna say the interval is 0 to 4. Okay. So let's see what we have here. All right. So first thing we want to do, step one, we want to find f at the critical number. So that means we need to find the derivative of the function and then find where it's equal to zero and then find where it doesn't exist. So we want to find f prime of x. So that's going to be equal to, you got the product rule here, first times the derivative of the second plus the second times the derivative of the first. So first times the derivative of the second, what the derivative of what's in parentheses. So it's going to be -1 because that derivative of 4 is zero. Derivative of negative x is going to be -1 plus the second times the derivative of the first. Derivative of the first is going to be um the chain rule. So that's going to be 3/5 x to the 3/5 minus 1. So that's going to be x to the -2/5. Okay. All right, good. There we go. All right. So let's kind of clean it up a little bit. So one thing I'm going to do is going to ask myself if I were to, let's see, let me think about this for a second. If I were to factor out with each of these, so you have this term here and you have this term here. If I could factor out, um, let's see, a -2/5. So x to -2/5. What happens is, so it's just like dividing both of these by x to the -2/5. So that'd be, okay, is that what I want to do? Let me see if that's what I want to do. Um, 3/5 minus negative. Okay, yeah, yeah, yeah. Yeah, that's what I want to do. Okay. So 3/5, and then you factor out -2/5. So that's going to be 3/5 minus -2/5, which is x to the 5/5. So that's going to be negative x, okay? Because we subtracted a -2/5 from here, which means we added 2/5 to that exponent, okay? And then it's negative because it's negative here, and then plus, and we've effectively factored this out. You see? So -2/5 and then divided by, well, with that factored out, it just goes to 1. Okay, so then it's going to be x plus 3/5 times 4 minus x. Okay, so there's a bit going on here. So make sure that you look back through this and make sense of it. All right, so that becomes x to the -2/5 then in parentheses, you got negative x plus 12 over 5 um minus 3x over 5. Okay. Now, let's see if we can clean this up a little bit more. So this can be written as x to the negative 2/5. Then you have let's see. So negative that's like negative 5x over 5. So it's going to be 12 over 5 minus um 8x over 5. And I'll write it finally as this here. So f prime of x equals 12 minus 8x over, they're both over 5, and then you have to consider this is a negative exponent. We can write it as a positive exponent in the denominator. So that's 5x to the 2/5. Okay. Again, so I know a lot is going on there, so make sure that you confirm that that is good. Now, all we've done is find the derivative. Next thing that we need to do is we need to set the derivative equal to 0, and we need to find out where it doesn't exist to confirm the critical numbers. The critical numbers are x values. Okay. So we're going to set this derivative equal to 0. So 12 minus 8x over 5x to the 2/5 equals 0. By cross multiplication, you have um, 12 minus 8x equals 0. 12 equals 8x. Divide both sides by 8. And then x is equal to 12 divided by 8, which is going to be, what's that? 3 over 2. So this is a critical number right here. Okay. Now, so that's where x value where the derivative is equal to 0. What about doesn't exist? So we know that pretty much you know a function something doesn't exist, the derivative doesn't exist when you have a fraction and the denominator goes to 0. Whenever you have a 0 in the denominator, does not exist. So basically, we know looking at eyeballing this, we know that, and I'm just going to write this, that x equals 0 is also a critical number because that's a value for which the derivative will not exist here. Okay. So those are our critical numbers. Now, what's step number 2? Step number 2, let me scroll up, is to find f at the interval endpoints. Okay. So f at the interval endpoints. You have f of a and f of b. So our interval is right here. So what is f of 0? F of 0, you plug in a 4 there. So that's going to be 0 times 4. So I just write it in. So it's going to be 0 to the 3/5 times 4 minus 0. 4 minus 0 is 4. 0 to the 3/5 is 0. That's just 0. Okay. What about f of 4? F of 4 is going to be 4 to the 3/5 times 4 minus 4. Since this goes to 0, this is also 0. So you see, these are the values of our endpoints at f of 0 and then at f of 4. Now, step number 3 is to compare. The largest is the oh, okay. I see. Another thing that we have to do is that I forgot for step 1, we need to plug these values back into the function, and then what the we need to see from there what the actual function values are. So I apologize, I forgot to put that on here. So what is f of 3 over 2? That's going to be equal to 3/2 to the 2, I mean to the 3/5 power, okay, times 4 minus 3 halves. So that ends up being 3 over 2 to the 3/5 power. And then 4 minus 3 halves is just like 8 over 2 minus 3 over 2. 8. So that's going to be times 5 over 2. Okay. So let's go ahead and pull out some calculator here because I don't know what 3 halves of the 3/5 power is off the top of my head. 3 halves to the 3 fifths power. Okay. And then times 5 halves. So I'm going to round it to the nearest hundred. So that's going to be 3.19. Okay. Approximately. But what about F at 0? Well, already, since I skipped ahead to step number 2, we already know that F of 0 is going to be 0, right? Okay. So then now we want to compare, to find what the absolute maximum is. So the absolute maximum is at, put a colon there. The absolute maximum is um F of 3 halves equals 3.19. Okay. Because we're comparing, let me do another color here. And you see how this happens to be the F of 0, which is like a does not exist point for this particular derivative, is also a an endpoint for this particular problem. Okay. And then absolute min, really you have F is equal to 0 at various points. So in the interval, the minimum we'll say is that F is equal to 0, F of 0. Okay. But keep in mind that F at 4 also equals to 0. So there really is 0 is the lowest that it goes, in other words, but it goes to 0 at a couple of different points. Okay, so hopefully that makes sense. Okay, let's keep on going. Let's do one more example because I don't want this video to be too long. I have a few examples on here. So let's say our function is f of x equals 5x squared plus 4x. So we want to find the hold on a second. Did I not put the interval on here as well? Okay, sorry. I'm actually looking at the wrong page. Sorry. That's not the example I want to do. Okay. All right. So let's do this example here. Now I see that I was kind of looking at some of the wrong notes. Now it kind of makes sense, even with this previous example. So this is actually supposed to be x minus 2 sine x, and then that's the interval. So therefore, sorry about that. The derivative is going to be 1 minus 2 cosine x because the derivative of x is just 1. The derivative of negative 2 sine x is negative 2 derivative sine is cosine. So here we go. Okay, now we're good. Now we're good. Now, remember, we're finding the critical numbers. So we want to find where the derivative is equal to 0. So we're going to set this equal to 0. 1 minus 2 cosine x equals 0. 1 equals 2 cosine x. So then cosine of x is equal to 1/2. And then you have to know, kind of like remember the unit circle to do the cosine inverse. Um, so cosine inverse of 1/2 is equal to x. So where on the unit circle is cosine going to be equal to one? Let me see, 1/2. So cosine is equal to 1/2. Let's see, you have that's going to be pi. X is equal to pi over 6. Is that correct? Oh, sorry. No, not pi over 6. It's going to be pi over 3. let me see. Right. Okay, yeah, yeah. So pi over three, because that's going to be whenever cosine is at its more lower point. So that's going to be, yep, okay, pi over three. And considering the unit circle, 5 pi over three. So if you don't remember that, that's just something that you kind of need to know from the unit circle. Let's see, pi over three is okay. All right. Anyway, and so then, so these are our critical numbers here. These are where our critical numbers are. X is equal to this, and x is equal to pi over three. Now we want to find f at pi over three, and then we also want to find f at 5 pi over three. Okay. Now, so f at pi over three is going to be pi over three minus 2 sine pi over 3. That equals pi over 3 minus 2. What is sine of pi over 3? So we know that cosine at pi over 3 is 1/2. And then sine at pi over 3 is root 3 over 2. Oh, okay. So root 3 over 2 goes here. These twos are going to cancel. So f at pi over 3 is going to be pi over 3 minus root 3, which I'm just going to put in parentheses, or just going to find the actual value for it so we can kind of know. So that's pi over 3 minus the square root of 3. Okay, so that is approximately 0. Negative 0.68 um 5. Okay. So what about f at 5 pi over 3? That's going to be equal to 5 pi over 3 um minus 2 sine 5 pi over 3. Okay. Let's rewrite that part. Minus 2. Now what is sine at 5 pi over 3? So 5 pi over 3 is going to be kind of it's going to be in the fourth quadrant of the unit circle. So that means it's going to be essentially what sine was up here, except it's going to be the negative. So it's going to be negative root 3 over 2. Those twos go away. So it's going to be 5 pi over 3 plus root 3. Okay. And so then that's going to be equal to, and I'll still do it here, even though I have it on my paper. Okay. 5 pi over 3 plus root 3. But hold on, did I do that right? Oh, oops. 5 pi over 3 plus root 3. Okay, point six. I mean 6.97. So I meant to say or 6.97. Okay, so so we found the value of the function at the critical numbers. Now the next step is we need to find the value of the function at the endpoints. So the endpoints were 0 and 2 pi. So what is f of 0? And then we want to find what f of 2 pi is. So the function is x minus 2 sine x. So f of 0 is going to be equal to 0 minus 2 sine 0. Okay, so we know on the unit circle, the sine at 0 is going to be 0. So this goes away to 0. So that's just 0. Okay, what about f of 2 pi? So that's going to be 2 pi minus 2 sine 2 pi. Now, 2 pi is the same location pretty much as 0. So the sine at 2 pi is also 0. So this is going to be 2 minus 2 times 0. I mean, 2 pi minus 2 times 0. So it's going to be equal to um, 2 pi. Okay. Which we need to find in decimal form, that is or approximately 6.283. Okay. Now, next step is to compare. So let's use some colors here. So this is one of the critical values, negative 0.685. This is one of the critical values, 6.97. And then you have the other ones. Then you have f of 0 is 0, and then f at 2 pi is 6.283. What's the highest point? So these are our absolute maximum and minimum on this interval. So our absolute max is located at rather f of 5 pi over 3 equals, and I'm just going to write it in this form because this is the exact value. When you write a decimal, you're kind of approximating. And then the absolute minimum is equal to this one at the other critical number. So that's f of pi over 3 equals pi over 3 minus root 3. That's the exact value of where you get this approximation. Okay. Let me know if something that I said doesn't make sense here, but these are absolute maximum and minimum values when we compare the critical numbers to, I mean, the function values at the critical numbers to the function values at the endpoints. Okay. All right. Again, let me know if I need to clear anything up for you. And make sure you share with a friend. And yep, that's all I got for you. Have a good day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.